Okay, so welcome back to another video. So today's video, we have a nice little algebra problem. If we're given that x cubed plus 1 over x cubed is equal to 1, then what does x to the power 5 plus 1 over x to the power 5 quantity cubed minus 1 divided by x to the 5 plus 1 divided by x to the power 5 is equal to? So I think this is an interesting problem for one that, and I'm going to go a little bit off tangent just for a little bit before we get to, the whole meat and grind of this algebra problem. I noticed that a lot of the practice examination problems where if you're given some value, then you have to find another value. But how that actually plays out is more in terms of if you take what you want to solve for and simplify it in a way such that if you can actually substitute the given, then plug that back in, then you get your answer. So you see that a lot in these practice examinations like SATs, ACTs, even these admissions, testings. But if you were to play out with that procedure in this situation like this, it's actually a lot difficult and it wouldn't actually get you anywhere to that point. So just for sometimes a rule of thumb is that you don't always want to rely on situations with that procedure like that. Otherwise, it's going to get you nowhere. Instead, we take more things into a little more of a brute force and show that we can find an x value that actually satisfies our given. And if we can do that, we can actually just plug that x back into everything into here, and then we get the following. So that's basically just the layman's term and layout on how we're going to solve this problem. So other than that, let's actually just jump right in. So if we want to solve for x on its own, so I have x cubed plus 1 over x cubed equals 1. So let's actually put this together so we don't have a rational function. So let's actually multiply x cubed to both sides. So x to the power 6 and then plus 1, then set that equal to x cubed. Now let's actually get this all together so that this is the right-hand side is equal to 0. So in terms of a polynomial function, so x to the power 6 minus x cubed and then plus 1 equals 0. So if we want to, we can actually take the long way and actually factor all this out, but that'll take forever since we have the 6 degrees, so we're gonna be here all day if that's the case. And another way we can do this, let's actually just take a little bit of a shortcut and actually do a substitution. So suppose we'll let x, or rather, we'll let t equals x cubed. Let t equals x cubed. And so with this in mind, that means I have now this is gonna be t squared, then subtract t plus 1 equals 0. So that looks a little bit easier to factor out, right? Well, not in the easier run, but you can tell that we can actually, of course, apply quadratic formula. So now if we actually put in the right coefficients, so I have now 1 plus or minus the square root of this is negative 1 squared minus 4 times 1, then times 1. As you can see with our discriminant over here, that this is actually going to be a negative input. So in this case, we know that we're going to have an imaginary number. So we have t is equal to 1 plus or minus the square root of negative 3 divided by 2. In other words, to put that into another way is 1 plus or minus I times the square root of 3 divided by 2. Okay, so we have two different solutions of plus and minus, but another way is that we can actually, to make things a little bit interesting, that we split this up as 1/2 plus slash minus I square root of 3 divided by 2. And if you notice that with the values in hand, we can actually put this in terms of Euler's formula and notice that this is the same thing as cosine of pi divided by 3 plus or minus I times sine of pi divided by 3. And in other words, by that definition, in terms of the exponential function, this is the same thing as e to the power I, well, plus or minus I times pi divided by 3. We have that t is equal to this following over here. So what that, of course, that doesn't mean it's x on its own, so we actually want to solve for x. So simple enough, all we have to do is just take the cube of both sides and see that therefore that x is just equal to e to the power plus or minus I times pi divided by 9. That's nice that we at least solve for a variable on its own. Then of course we can actually just plug in back into all this. So let's actually take things one step at a time. That now we have an x to the power 5 plus 1 over x to the power 5. So let's actually get that out of the way first. So x to the power 5 plus 1 divided by x to the power 5. In other words, we plug this back in. So keep in mind I have a plus and minus case. So of course it's always doable and it's always the good, choice that you want to do in two different cases. So let's actually do that. So we'll actually just doing the positive case first. So that means I have e to the power I, then 5 pi divided by 9, and then add this with 1 divided by e to the power I times 5 pi divided by 9. In other words, that can be rewritten as e to the power I 5 pi divided by 9. Add this with e to the negative I 5 pi divided by 9. Okay, so let's suppose that now we have that in mind, so let's actually do in the negative case, so negative I 5 pi divided by 9. So e, then minus I 5 pi divided by 9, and then add this with 1 divided by e to the negative I 5 pi divided by 9. And if you rewrite this, so that's the same thing as e to the negative I 5 pi divided by 9, then add this with e to the power I 5 pi divided by 9, and you'll notice that these two are actually the same thing. So it doesn't matter plus or minus. Well, I guess in this situation, I guess in some cases it does matter, but here in this case that they're both the same thing, so it doesn't matter which it is, you're going to get the same value. So that's perfect on that part. So now that we have this value, how can we take things one step further? Let's actually now multiply and divide a 2. So why do we do something like this? So first I'll write down 2 and then times e to the power. I'm actually just going to stick with the positive and then follow with that negative of the exponent just because it's just because. Then I times 5 pi divided by 9, add this with e to the negative I 5 pi divided by 9. And then if I divide by 2, you'll notice that in what's in the parentheses, this is in terms of the definition of the exponential of cosine of the input. So that means this is the same thing as 2 times cosine of 5 pi divided by 9. Okay, so at least we have that this is equal to x to the power 5. Then add this with 1 divided by x to the power 5. So now, of course, we have that for the denominator, but now we have to cube this. That's actually not a big deal. So that means, in other words, this is going to be, so let me write out this in full, x 5, 1 divided by x 5, then cube, then subtract 1, then divided by the same thing on the top. So that means if I cube this, that means this is going to be 8 times cosine cube of 5 pi divided by 9, then subtract 1, all being divided by 2 cosine of 5 pi divided by 9. So we're not done there. You may think that this is as simple as it gets, but we can actually apply a little trig identity over here such that cosine cube of x is the same thing as 1 divided by 4 multiplied by 3 cosine of x. Then add this with cosine of 3x. So we can actually plug that substitution back in and say that if I plug 8 cosine cube of 5 pi divided by 9, then that's the same thing as 2 times 3 cosine of 5 pi divided by 9, and then add this with cosine of, this is going to be 5 pi divided by 3. Okay, and then of course this is going to be now subtract 1. And then same thing from the denominator over here, nothing has changed. Then we notice that cosine of 5, now if I distribute everything, of course I gotta do that first. So 6 cosine of 5 pi divided by 9, and then add this with 2 cosine of 5 pi divided by 3 minus 1. Then under the denominator, then the same thing, but you'll notice that cosine of 5 pi divided by 3 is equal to just 1/2. So I have 2 times 1/2 is 1, subtract 1 is equal to 0. And so therefore we're just left with 6 cosine of 5 pi divided by 9, then divided by 2 times cosine of 5 pi divided by 9. These cancel, and so therefore it just simplifies down to just 3, which is the final answer for this nice little algebra problem that can't always rely on, simple tricks. You gotta, take it with, brute force, in other words. So there we have it. So yeah, so there you have it. There we go. So yeah, that's pretty cool if you ask me.